Problem number 16. Two 12-volt batteries with internal resistance of 0.2 ohm and 0.25 ohm respectively are joined in parallel, and a resistance of 1 ohm is placed across the terminals. Find the current supplied by each battery. So this was the figure which was explained in the question. So here we have two batteries of 12 volt, and we have an internal resistance of one is of 0.2 ohms and another one is 0.25 ohms, and 1 ohm resistance is placed across the terminals. So we have to find the current supplied to the each battery. So as we know that current from this battery, let us take it as I1, and from this we will take it as I2. So that two currents will be added to the resistance, that is I1 plus I2 across the 1 ohm resistance. So let us use Kirchhoff voltage law for this loop. The loop is A, B, C, F and A. So for loop A, B, C, F and A, let us write the Kirchhoff law, that is 12 minus I1 0.2 minus I1 plus I2 is equal to 0. So when we simplify this, we will get as 1.2 I1 plus I2 is equal to 12. So this is the equation. This is the equation 1. So let us consider loop F, C, D, E, F. So using Kirchhoff law again, 12 minus 0.25 I2 minus I1 plus I2 is equal to 0. When we simplify this, we will get I1 plus 1.25 I2 is equal to 12. So this is a second equation. So using equation 1 and equation 2, we can substitute like this. So we will multiply equation 2 to 1.25. We will get this equation, and simplifying this, we'll get I2 as 4.8 amps. So using this I2, we can find out I1. That is, we know the equation I2. So we'll substitute any one value here. So let us substitute here 1.2 I1 plus 4.8. So when we send 4.8, that's it, we get I1 is equal to 12 minus 4.8 divided by 1.2. So this will be like 6.8. So simplifying, we'll get I is equal to 6 amps. Problem number 17. In this problem, they have given a circuit where we have to find E1, E2 and I. So they have also given the power dissipated in 5 ohm resistance, that is 125 watt. So using first law, we can find that the current flowing through the 5 ohm resistance will be I plus 2.5. So this is I and this is 2.5. So this current will flow in the 5 ohm resistance. So using Kirchhoff's second law, that is voltage law, we will find the E values. So first for the loop A, B, C, F, A, we'll first find the loop. So E1 minus 3I is equal to E2 minus 2 into 2.5. So we'll get it as E1 minus E2 minus 3I is equal to, so this will be a 5. So this will be first equation as given here. Next loop is FCDE F. So we'll again find the loop. So E2 is equal to 2 into 2.5 plus, so 5 into I plus 2.5. So this will be the second equation. When we simplify this, we'll get 5 plus 5I plus 12, we'll get 12.5. So further simplifying, E2 will get 5I plus 17.5. So this is our second equation as given here. So further they have given that the power across through the 5 ohm resistance across 5 ohm resistance 125. So we know power formula VI. We further simplify this, we will get I square R. So we know I is nothing but I plus 2.5 square and R is 5. So we know power 125. So when we send this to this side, we will get I plus 2.5, which is on square. We will get 125 divided by 5 is 25. So when we send the square root the other side, that is 25, we will get 5. So I is equal to 5 minus 2.5. So I is nothing but 2.5 amps. So when we substitute this I value here, this will become 7.5, and when that goes that side, we'll have, so when we substitute another I here, we'll get 12.5, which is nothing but E2 will become 30 as given here. So once we get E2 30, we'll simplify this in the equation number 1 and we'll get E1 as 32.5. So final answer will be 32.5 volts, 30 volts, and I is 2.5 amps. Problem number 18. So two storage battery A and B are connected in parallel to supply a load of 0.3 ohm. The open circuit EMF of A is 11.7 volts and B is 12.3 volts. The internal resistance of 0.06 ohm and 0.5 ohm respectively. So find the current supply. So they have explained the circuit. So finally we have to find I. So this I is nothing but I1 plus I2. I1 is the current from battery A and I2 from battery 2. So we know that I is equal to I1 plus I2. So using Kirchhoff's second law, that is voltage law, so we will find one loop, that is this loop. So that will be A, B, C, D, A. So when we apply Kirchhoff's second law, we will get it as 11.7 minus 0.06 I1 is equal to 12.3 minus 0.005 I2. So this is the equation. When we simplify it, we will get when we simplify this, we will get 0.06 I1 minus 0.05 I2 is equal to minus 0.6. So this is the equation 1 which has been written here. So this is the equation 1. The same Kirchhoff's second law for the loop 2. That may be a loop 2 which is going as I am showing. So this is loop 2. So that will be of F, B, C, G. So this is across F, B, C, G, F. So when we write, we'll get 11.7 minus 0.06 I1 minus 0.3 I is equal to 0. So when we simplify this also, we'll get 0.36 I1 plus 0.3 I2 is equal to 11.7. So this is the second equation. So using equation 1 and equation 2, when we simplify by multiplying 6 to equation 1, we'll get equation 1 as this. And simplifying those two, we'll get I2 value. I2 value is 25.5 amps. So using this I1, we will substitute in any of the one equation, that is 1 or 2, to get I1 value. So I1 will be 11.25. So once we get I1 and I2, we know I is nothing but the addition of I1 and I2. That is nothing but 36.75 amps. So we have found out the current which will flow across 3.3 ohm resistance. Problem number 19. Find current in 15 ohm resistor, voltage across 18 ohm resistor, and power dissipated in 7 ohm resistor. So this is the figure. So first we have to find the current across this 15 ohm resistor. So that will be I1 plus I2. So let us call this as IE. So next, so first we have to calculate IE. So next we have to calculate, find the voltage across 18 ohm resistor. So let us call this as V18. So V18 we have to find out. Third is power dissipated at 7 ohm resistance. So let us call it as P7. So P7 we have to find. So these three we have to find from this figure. So first we will find the resistance across this parallel combination, that is A and B. So equivalent resistance across A and B is RAB, which is 9 into 18 divided by 9 plus 18 will be 6 ohm. So this is 6 ohm. So now we'll use the Kirchhoff voltage law, that is second law, from the meshes. First mesh is P, Q, R, U, P. So the mesh will goes like this. So when we write the mesh equation, we'll get 10 I1 is equal to 9 I2. So this is the first equation. So next the mesh is URSTU. So this mesh goes like this. So when we simplify, we'll get the second equation as shown here. So multiplying 3 to equation number 1 and multiplying 2 to equation number 2, we can simplify and get the I2 value. So I2 will be 3.33 amps. So using this, simplifying this value in any one of the equation, that is equation 1 or equation 2, we will get I1 as 3 amps. So as we know, EI, equivalent current, is I1 plus I2. So the total current will be 6.33 amps. So we found out the first one, that is IE. So next one is we have to find out the voltage across 18 ohm resistance. For that we need I4. To find I4, using I1, we will simplify I3, that is I1 into 18 by 9 plus 18. I3 will be 2 amps. Using this, we know that I1 minus I3 is I4. We will get I4 as 1 amp. So voltage across 18 is 18 into I4, that is 18 volts. Next is P7. So power will be I2 square into 7. So we know I2 square, that is 3.33. So simplifying that, we will get 77.62 watts. This is the power it has given here. Problem number 20. Determine the magnitude and direction of the current in the 2-volt battery as shown in the circuit below. So magnitude is nothing but the value of current, and we have to find the direction of the current. So first, the 2-volt as shown in the figure. So they are telling us to find the value of the magnitude of I2 and which direction it is flowing. So using Kirchhoff's first law, we can tell that this 2-volt is producing I2 and this 4-volt is producing I1 and this 3-volt producing maybe I3. So this will be equal to I3 and this will be again equal to I3. So here I1, it's splitting into I2 and I3, or I1 is I1 minus I2, which is I3 to the third branch. So we have shown the direction. Now we have to find the magnitude of I2, that is the current in the 2-volt battery. So we will use Kirchhoff's second law, that is voltage law. So this loop and this loop. So first loop is nothing but A, B, C, F, A. So for this, when we simplify, we will get 4 minus 2I1 minus 3I2 plus 2 is equal to 0. So when we further simplify this, we will get 2I1 plus 3I2 is equal to 6. So this is the first equation, right? So this is the first equation as shown here. So when we take the loop F, C, D, E, F, again we'll have the loop F, C, D, E, F. So this is the second loop. So this will be equal to 2 minus 3I2 is equal to 3 minus 1.5 to I1 minus I2. So when we further simplify, we will get equation 2. So multiplying 3 to equation 1 and multiplying 4 to equation 2, we will get this 2 as equal, so that when we simplify it, we will get I2. I2 is nothing but 0.52. So we have found the direction as shown in the circuit, and also we have found out the magnitude for the current in the battery, 2-volt battery, that is 0.52 amps.